Hello, I'm Fabrice. Today I'm going to talk about how to mathematically prove some Python code. Let's start with an example that is what we want to achieve. What I want to do is given a piece of Python code, here classify number, a function which returns the number of negative, positive, or zero in an array. I want to mathematically prove that the sum of the three elements returned is actually the size of the initial array. So here I'm writing that with some mathematical symbols which are put into comments. In order for the proof to be automatic, I need to add some loop invariant, and thanks to the loop invariant which are being added here, it works fine. So how are we going to do that by only using LM? This is what I'm going to talk about. So first, I'm going to state my problem. What I want to achieve is I want to use a weakest precondition, which is a kind of formal method, in order to do some proof on Python code. Uh, in this case, I'm using Gemini, which is proposing me some way of doing the notation. Great, I'm going to follow this advice. I continue to discuss to understand what is the best architecture, which is the most suited to that. And I end up with five Python scripts. Right away, I'm generating some skills in order to make sure that I will be able to modify those scripts through some LLM and not do that by myself. Now, the code actually that I got now is fairly, I would say, fresh out of the press. So it has a lot of errors. It's not working fine. So what I'm doing is I'm generating 20 programs in Python that I would like an annotation agent to actually annotate. So I add both the annotation agent and the skills associated. If everything is fine, that is, if it passes the test with the previously generated Python, then it's good. The reconciliation agent has nothing to do. Otherwise, the reconciliation agent is going to, given what is having as data, it's maybe the original Python analyzer, which is wrong, or the example or the annotation is going to determine who is the guilty agent, is going then to give some information to an update skill, which job is actually to edit and modify, for instance, the annotation agent or the original Python code that we wrote. So here, this is an example of a discussion that we're having, where I'm going to change some skills of the annotation thanks to the update based on some errors that I'm seeing in some files. In order to make sure that this set of free agent is working fine, what I'm going to do is I'm going to add some meta agent, which are going to supervise what is going on. So I have the reviewer who is going to write some human readable PR description that helps me to basically better understand what is going on, what are the changes which are occurring. Then I will have the evaluator, which is going to measure how well my code is able to go through PySCL, which is the name I gave to the executable, and we have the monitor, which is going to make sure the quality of the data which are generated. Is the MCI server happy? Is the JSON? Are there some failure in the JSON file? This is exactly this kind of stuff to make sure that I'm kind of controlling what is going on. I ended up with 50 tests, 1,200 lines of Python, plus the comments, which are actually the mathematical proof, and all the tests are passing. I'm definitely super happy. This is exactly the kind of things I wanted to achieve, and it's available on GitHub. Regarding the positive points, we were able to model the standard control structure through our loop of agent. We were able to do some common data structure like list, arrays, also 2D arrays. And we were able to handle several memory models that compensate for the absence of separation of logic. We have a very, I would say, simple way of doing it, but we compensate that by some different, I would say, memory models, which can be very fine-grained, very close to C, or more high level if need be. And to finish, the limitation currency, we didn't address some topics such as concurrency, and the skill source to be large. So we're having 1,700 line of skills over four files, which is kind of big. So at some point, it could be better to switch to RAD or RLM.